Thank you very much indeed, Eugene, and thank you to those participants who are sending us in questions. We do have questions, but we're going to take them in a group and do the Q&A together just before the coffee. So I'd like to welcome now Alan Freeman, who's on behalf of Veolia working at Pfizer Grange Castle, and going to talk about ISO 50001 and how it's helped some of the sites that it's involved in comply with the energy audit scheme. Okay.
Hello everybody, my name is Alan Freeman. I'm an energy manager with Veolia. Just want to say, first of all, I'm honoured to be asked to speak at this event. What I'm going to talk about today is ISO 50001 and hopefully try to take you through the journey to achieve certification to ISO 50001. The goal of this presentation is to bring value to the audience, and hopefully you can implement some of the ideas or processes we speak about in your own site. So what I'm going to speak about today is I'm going to speak a little bit about my background and experience, a little bit about Veolia's link to the pharmaceutical industry. I'm going to talk about implementing ISO 50001. I'm going to give you a 6-step guide. I'm going to talk about some of the improvements which we've seen on different sites, and I'm going to give you an example of what I classify as a mature ISO 50001 system. My experience or my education, I did a master's in energy management, graduated in 2012, and I did a thesis around implementing ISO 50001 in 2012. And at that stage there wasn't an awful lot of material around there, so I probably picked a bad topic, but I got there in the end. I operate Veolia's Hubgrade, which is a real-time energy monitoring service, so we take information from a number of sites around the country. We set alarms, set parameters, set reporting templates, and we keep our clients happy that way. I've also completed a number of energy audits, but I suppose my main role within Veolia is to implement ISO 50001 systems and to maintain them. So I've done that in Ballina Beverages, which is a Coca-Cola site. I've done that in eBay, I've done one in PayPal. Currently implementing one in Pfizer Grange Castle, where we had the stage 1 audit last week. Whitfield Clinic is a private hospital in Waterford. And we've also had some queries from New York, from our colleagues in North America, about implementing a system and the MTA. So Veolia is linked to the pharmaceutical sector. Veolia have 3 strands to their business. They have a waste business, water, and then energy, where I sit in our office in Glasnevin. We have 25 years experience in the pharmaceutical sector. Some of our clients are mentioned there. Just on Connor's point about finance earlier, Veolia do provide finance for energy saving projects. So now we'll get into the bones of my presentation. Step 1, the 6 steps to certification. So step 1, which I feel is probably the most important one, is your data analysis. It's deliberately a big step there, so I'm going to spend a lot of the next 10 or 12 minutes talking about data analysis and different techniques. The next step is development of your energy team. We're going to look at operational control and some of the savings we've achieved in different sites. We're going to look at design and procurement, whole life cycle costing, why that's important. Internal audit regime must be implemented on your site. You also have a need to edit existing corporate documentation, and then a management review is probably your final step on your road to certification. And I've just put in a pot of gold up at the top, so that's your certification. While we're doing the whole standard, we need to have a monitoring and measurement procedure all through the process. We'll see the value and the importance of that. Okay, so step 1 on your data and analysis is to produce an energy review and planning process. We normally do it in a document, so historic energy use. We look at trends across your site, typically over the last 3 years, is what we've done on sites, if that data is available. The next step is to develop your baseline and compare your current data against that baseline. So in this graph, it's just an example. Just want to say at this point as well that all the figures I've used in this is indicative, because we like to protect the confidentiality of our clients. So our baseline here is 2014. So we can see a consistent electricity consumption. We compared in 2015 against that. So in this example, we can see a 3 or 4% decrease month on month. So the next step is to develop your energy balance for your site, which will help you identify your significant energy users. So for this example, we can see that refrigeration is a quarter, HVAC is a quarter, utilities is a quarter. So if I see in that graph, I would be recommending that we concentrate on them 3 areas so that you get 3/4 of your electrical consumption in them 3 significant energy users. So you put your resources in against identifying opportunities for saving, particularly in them 3. Okay? We're going to spend the next number of slides on energy performance indicators, some that we use on sites. There's obviously your site might be different to other sites, so this is where you need to identify your variables which affect energy use and link them through regression analysis. So regression analysis we use here. So we have an example of HVAC, which is heating, ventilation and air conditioning. So the total steam to heat a facility is this example. So your kgs of steam is down on your x-axis. We have a thing called degree days on your y-axis. So degree days is directly linked to your outside air temperature. So the colder it is, the more steam is required to heat the building. So we look at, this is typically summer months, so you have a less of a heating requirement. This is typically winter months, okay? So why is that important, or why do we use that? Once we do the regression analysis, we get an equation like this, and an R² value of 87. The R² value means that 87% of the HVAC steam is related to the outside air temperature. Okay, so we would consider that a strong correlation. So when we plot that equation down here into our formula, we can do 2 things. One thing is we can predict our future energy use for that particular significant energy user. So we can say, based on the variable, which is the outside air temperature, for this example, we can say average temperature for the next 12 months is X. So we plot them in monthly there. We can predict what we're going to use, which helps, I suppose, facility managers and managers in general to predict their costs, which helps. The second thing is we actually measure our own performance against that significant energy user, against your predicted, okay? So for this example, we had a project where we increased our efficiency, our thermal efficiency of our CHP unit, therefore we used less gas to heat our building, okay? And we can see there that graph is basically taken out of the table just before. So this is what we predicted in graphical terms. That's our predicted energy use, and these orange blocks are what we actually use. We'll see quite significant savings there month on month. Okay? Staying with energy performance indicators, we're going to move on to efficiency and efficiency trackers of your main plant and main equipment on your site. So the example here is steam boilers. So we're going to look at monthly efficiency tracker. So we take our gas consumption in kilowatt hours, plot it every month. We get our steam generated, which is typically in tons. We convert that to kilowatt hours so we can divide one end to the other, and it gives our efficiency for that month. Okay? Winter months are slightly higher because it's seasonal. You can see it in the red outline. It's typical for a site. Again, these figures are indicative. Our next example, which is a little bit busy, I'm just going to concentrate on the information inside the black box. So this is the CHP, which is a combined heat and power plant efficiency tracker. So we look at our gas consumption once again and our electricity generated. So we can divide one into the other, and it gives us this electricity efficiency, okay? So we track that month on month, ongoing monitoring and measurement, which we mentioned earlier. We also have a thermal efficiency, so it'd be your medium temperature hot water and your steam combined in kilowatts divided by that gives you your thermal efficiency. So this last line then gives your overall CHP efficiency. So why is this important, or why would you track your efficiency? So we can see here, for example, if you were doing a monthly tracker, you can see October 15, okay, gas is slightly lower maybe, a lot lower in electricity produced, a lot lower everything, right, our efficiency. there's a problem here. We're at 33%, we should be over 40. Overall efficiency is down 15%, so we're catching these efficiency or losses in real time rather than reacting 3 or 4 or 5 months or sometimes 12 months down the line. So that's the value of ongoing monitoring and measurement of your energy performance indicators. Again, they're not that hard to implement. If you want to put them onto your own site, hopefully you can find value in them. Just energy use metrics. Again, different type of site. We have two here. So we've our energy use per occupancy, and we've energy use per metre square per floor area. So we just take this example, the blue example first. So site X and site Y. We can see site X monthly uses 216 kilowatt hours per occupant per month. Okay? So we're consistent month on month. Again, the value of ongoing monitoring and measurement, we can investigate, say, okay, we're 15% over where we should be. This example, why is that? So it could be, for example, it could be an extremely cold December. If that's it, then we can verify and put it to bed. If it's not, then we need to get deeper into that problem. There could be a large steam leak, there could be something with a large electricity load that wasn't on before, that was put on and left on. Site Y then, just I suppose a different example, we can see that it is almost double site X, okay? So we could have a site that is occupied 50%, 60% of the time, okay? So they're in a recruitment or growth area at the moment. So they look to recruit maybe 40% more people over the course of the following year. So while your electricity and gas energy might be climbing, this metric will actually drop down and you will become more efficient per occupant. So you could be increasing your electricity by 10%, but your actual energy use per occupant could be dropping down closer to where site X is. Okay? So they're good to have, especially if you're in a growth phase. The second example is similar. So we've site X and site Y. So it's the megajoules of energy versus square meterage. So this is ideal for loads of different industry, for benchmark. So you can, if you have a site here in Dublin and you have a sister site or a similar site in London or Paris or the United States, you can use this metric to track your performance against their performance and see how efficient you are. And you could do it in terms of a league table. This site has 251, they're 255, but also you can track ongoing as well. There's no large deviation in that. So that's the value of them two particular performance indicators. I'm going to park the data and analysis section now, and I'm going to move on to the energy team. So why is it important to have a good energy team? Basically, there's a lot of clauses in ISO 50001 which needs to be met, and you can't meet them individually. You need to have a dedicated, a structured and dedicated energy team willing to buy into energy and energy management and energy savings. Okay? My experience in this, it'd be great to get engineers, facility, utilities people involved. They have an interest in energy saving and cost reductions. It's also good to get production managers and production people involved in this as well, because sometimes production people can be just completely focused on production and getting product out the door. Okay, so if you can get them as part of your energy team, you can educate them on the amount of energy they use per CIP, or if they half run a CIP and they run a second or a third one, just to be sure, you can actually give them a cost for that steam and that water and the energy used in that. So it's all about education and awareness and training of people who influence energy use. So what's the energy team responsible for? So you need to develop an energy management system manual which references all the clauses of the standard. So when an auditor comes into your site, the first thing he's going to ask for is a manual to point them in the right direction. Next thing is an energy policy statement for your site or for your organisation, which identifies your goals and visions with regard to energy management and energy efficiency. You also need to set targets, annual targets. You need to set objectives to meet them targets or projects, and you have to have an action plan of how you're going to implement them objectives. We have done on other sites is a register opportunities, so any big or small or any size of energy saving projects goes onto your register opportunities. You have a method of verification attached to that. You've predicted energy savings, then you have responsibility and a due date. Seems to work well on some of our other sites. Other responsibilities is operational control. So you identify your main plant, your set points, your reason for them set points. Normally, or sometimes things are set up, and the reason they're set up is because they were always done like that in the past. So there is opportunities there to save. We have an example coming up. You also look at your maintenance of your machines. We all know energy or maintenance has a large impact on your energy use. Monitoring and measurement, ongoing. We've mentioned that, and we've seen the importance of that. Your internal audit system must be developed, and normally have an annual energy audit. Management review, so your energy performance and your significant energy users must be reported to top level management. Okay. Design and procurement and life cycle costing is also a change which we've implemented on some sites. So if you had a pump A, pump B, one was a few percent more efficient, but it was 100 or 200 euros more expensive. We need to get to the culture that we actually go for the most efficient piece of equipment, because it pays you back in the life cycle of that piece of equipment. Just some examples with very little or very little investment or non-investment in some of them. So we mentioned our CHP efficiency. When we did the tracker, we could benchmark our CHP against the best in class, and then when we go and investigate our thermal efficiency, we could improve that. We improved that by 8%. No cost, an automation change on a valve, fine, 8% led us to huge savings for last year. Refrigeration was another significant energy user we had on one of our sites. So our energy use for our electricity use for refrigeration was climbing, and we started asking the question, why is that? Why are we using more this year versus last year? So when we actually went down to the bones of it, we could see that the purpose of our freezers were there was 40% more freezer movement. So therefore, we had to change the operation of our freezer. We got energy saving projects in there to reduce that back down to where we needed it. Operational control and HVAC. So we've typically seen that we can influence. There's always opportunities with air change rates, areas that are, I suppose, getting too much air or are unoccupied for maybe the weekend or some evenings of the week. So you look at your timetable for your HVAC systems, and there's normally scope to make savings on that. And also for verification of we've done numerous LED light upgrades, and you verify your projects through your ongoing measurement and verification. So I just want to give you an example of a mature ISO 50001 system. So this is Survey in Wicklow. So they got certified in 2012. They currently have 11 established energy performance indicators. In 08 and 09, their metric was watt hours per box of production. So they were using 200 watts of energy to get one box out the door. Last year they used 117. And we'll see in the next graph, it's even more impressive when we see their production trends. Okay, employee awareness, life cycle costing, they also included scope, oil and water into their scope, and they had significant savings on their water side. And they've also been asked to roll out ISO 50001 across some of their other sites. So their energy savings year on year, we can see constantly making improvements and making changes to reduce their energy consumption. Okay? So here we can see that their production figures from 08, 09, right through to the present, to last year, they've increased year on year. Okay? So you'd expect your energy use to go up with production, but the projects that they have implemented through their ISO 50001 system has meant reduction year on year. They got rid of the oil in 2013, which is very impressive. Makes for good reading. The last slide on survey is that this is what they would be using today if they didn't go down the ISO 50001 route or didn't implement the projects. This is where they are. Okay? So I suppose the point of that slide is that when you save 100 kilowatts here, you don't just save it there, you save it over the life. You save it year on year. Okay? So it's an avoided energy cost continuous. Okay? Again, just to wrap up now, just to go through what we spoke about. So data and analysis, we looked at some examples of that. We spoke about how important it is to have a structured energy team. and not just an engineering energy team. Operational control, the importance, design, procurement, life cycle costing, internal audit regime, existing documents. We didn't go too much into that because every site is different and they all have their own documents and own procedures. Management review, then we spoke about. Okay. That is basically it. I'd like to thank you for taking the time out to listen to me. If there is any questions, you can get me afterwards, or my email address is there if you want to email them on to me. Thank you.